Easiest for me to think about a thermometer. Pretend this is your thermometer. This is really cold. This is a beautiful snowflake. It looks like a multiplication sign. This is very hot. It looks like fire, but it doesn't look like anything. So like our scale, 0 is pretty cold. At 32, you know, water's freezing. We get ice. Looks like ice, you know. We can get negative numbers as well. That's when it gets below 0, like -5, -10. So not to get like the nerdy math theory of anything, but the 0 is just like an idea we put on a line. Because if you've ever seen the Celsius scale, 0 is actually up here. And where this might come in is they might want to say how many degrees different are there. So let's say Chantel goes to Alaska and it's -40 degrees. And Ruth is in Hawaii and it is 75 degrees. So what's the difference in temperature here? Like how many degrees different are there? We could figure that out by dividing, or by seeing, well, there, and say this is 0. We'll say there is, there is 75 from 0 to 75 there. And then we'll say there's 40 here. So we could say 75 plus 40. That's going to equal, in my head, 115. Yeah, 115 degrees. I don't work these out with answer keys on purpose so that you see me actually working through the problem. So if I ever mess up my math or anything, just tell me. So you can see there's 115 degrees of difference between these in the thermometer. Another way we could say this is I put without making it negative. No, I don't want to do that. It's too math nerdy. Let's not do that. So what happens when we add and subtract negative numbers? So let's say we have 4 and we want to add -2. What are we actually doing here? Like, what's going to be the answer to 4 plus -2? Anyone want to throw out an answer? So when we add a negative number, it's actually subtraction. And I'm just putting in parentheses to show where the negative goes with. It actually becomes a subtraction. It becomes 2. And this is because it's like bringing it down. Think of it as like you're adding something that's making it smaller. Imagine if you have a bucket of water and you add ice to it, that actually brings it colder. It doesn't make it warm. It doesn't make it warmer. So when you add a negative, it takes away this sign. It's actually subtracting. So that's something to remember. Actually subtracting. I also can't spell on them at a board, so I probably mess it up a lot. So when you add a negative, you're actually subtracting. Now let's say we're subtracting a negative. What do we think this one might be based on what we just said?
You're adding?
Yeah, you're actually adding.
Because you do the opposite of whatever it is.
Yeah, you do the opposite whatever it is. These actually come together to make a plus. If it's helpful for you to think about it this way, you can pretend like it gets turned on its side and then makes a plus. That should be minus. I just would rather think about it, subtract a neg actually adding. There's not like a quiz about this or anything. It'll just come up and be important as you're doing the equations and that kind of thing to know that's what's going on. So here's a problem for each of you at work. You guys good with me to erase this? Great. And important point, does it offend you if I say guys and you're girls?
No.
Okay, I know some people, so I try not to do it, because like I just rather not offend people, but I just want to check, so. So why don't we try this one? 3 minus -4, and 5 plus -2. So why don't you try those on your own, and then I'll come look at them in a second. Eric, come on down and text me, so I'll do that real quick.
But how are you doing the problem? You're just doing the opposite of what it says?
Yeah, basically, when there's a net, you subtract a negative, it cancels out the negative and you're actually adding.
So that would be 7?
Yep. When there's a plus and a minus, you're actually subtracting. Yeah. So, yep, 3, okay, so that's good. That's the answer. Let's try one more. Actually, 2 more. Let's try it. 10 plus 5 minus 10. So what do we get here? Let's see, so you got 15, you got 15, good. I haven't actually worked it out yet. You're taking away 5, you end up taking away 5, you end up adding 10. Good, you're geniuses.
So to ask that people
Right?
that, do we get a waiver?
Your geniuses on negative numbers. So now we're going to talk about something called factors. Factors. And these are just like a few random topics we're covering at the start. So when we add numbers, let's say we're adding 2 times 3 equals 6. The factors are what add up to the number, or sorry, multiply, not add, what multiply to the number. So, to find all the factors of a number, you have to find every single number that adds up to a number. So actually for 6, the factors are 2 times 3, but you can also say 1 times 6 equals 6. So the factors of 6 are 1, 2, 3, and 6. So sometimes they'll say find all the factors of something. Let's do it with another number. Let's do it with 12. So let's find all the factors of 12. So what multiplies 12? Well, we have 1 times 2 equals 12. We have 2 times 6 equals 12. We could do 3 times 4 equals 12. Right? So now if we list all the factors, it'd be 1, 2, 3, 4. Sorry, 1 times 12.
I was looking at that like,
Yeah.
wait.
Yeah, no, 1 times 2 is 12, and 12. Those are the factors of 12. Why don't you all try? How about you all try this one now? Of 20. Why don't you all try that? What are the factors of 20?
got
set?
5 times 4 equals 20.
Yeah, let me see what all you've got.
That's what I got.
Got any other numbers that equal 20? Does. I think you got all of them. What else can you go with 20?
Let me see.
What? See what else
Yeah,
goes.
what's this one? Those are one of them?
Should be. Yeah, I can't think of anything else that goes to 20. So you got 1 and 20 and then 2 and 10. Now, let's talk about another one. What are all the factors of 13? What are we getting right here?
1 times 13 is 13.
It doesn't divide by 2 because it's an odd number, so is there anything else? It's just 1 and 13. We have a special name for this. A prime number. If you can find a prime number with like a million not decimal, like a million places, there's some big prize, like they got really smart computers trying to figure them out. But these prime numbers is the only factors are itself and 1. So that's when the only factors are itself and 1. Very interesting, right? Some other prime numbers, some random ones. There's 11, there's 17, there's 19, 23, I think. 31 is a prime number. You don't need to write those down. Those are just some examples of prime numbers. There's only one even prime number, and it's 2, because otherwise, like 4, they're all divisible by 2. You can divide them all by 2. Now, sometimes we want to do the prime factorization of a number. Don't ask me why. I don't know why anyone actually enjoys it, but sometimes we want to for purposes of becoming ASVAB experts. The prime factorization of a number. So, sometimes when you want to, let's use 12 as an example. Now you can write 12 like 12. You can also write 12 as 3 times 4. Now when we do the prime factorization, we make sure the number is written as only multiplied by prime numbers. Totally weird. So how you would write 12 is 3 times 2 times 2. That's because 2 times 2 is 4, and 4 times 3 is 12. You're trying to write it with only prime numbers, so it's going to end up very, very big. Let me get a good one for you. How about 36? If we wanted to write the prime factorization. Well, we know 36 is 6 times 6. And we know I'm going to write it beneath. 6 is 3 times 2. And 6 is 3 times 2. So this actually equals 36. And so let's do it out. 6 times 3 times 2 is 6. 6 times 3 is 18. So I'll write it, I'm just going to write it like this as 18. This isn't like a mappy way to write it. I'm just hoping you kind of understand what I'm doing if you're following. Then 18 times 2 is going to equal 36. So it all ends up equaling 36. But prime factorization is only prime numbers are used to write the number. There's another good one. It's usually gonna be like, it's usually just gonna be 2s and 3s, it might be another number. Why don't you all try to do a prime factorization of 15? If you know, let's try that one. Anyone have a shot at it?
Three times 5, and then it will be 2 times 3 times 3.
This is right. What's the next thing we're doing? 2 times 3 times 3? Let me see what we got. So this is fine because 5 and 3 are both prime numbers.
But don't you have to like keep
Breaking it down?
Yeah, like
Well,
2 times 3 times.
Yeah, we can't here because 5 doesn't break down into anything else. The only thing we can divide 5 by is 5, and that's still, or 1, and then that's 5. Does that make sense? Let's keep talking about it. So when we divide, this equals 15. Both of these are prime numbers because the only thing we can multiply 3 by to get 3 is 3 and 1. So this is a prime number. The only thing we can multiply 5 by to get 5 is, only thing we can multiply by to get 5 is 5 and 1, so it's a prime number. So since we have 2 prime numbers right here, that's the prime factorization.
Only those 2 numbers.
Only those 2 numbers, yeah. Now I'm gonna do a bigger number. And the way, so tell me what the prime factorization of 60 is. You can break this apart. Well, you can do it by breaking apart just anything you know that divides into 60. Try that and then try to break it into smaller and smaller pieces until they're all prime numbers.
Can we start with 10 times 6?
Yep, you can start with 10
That's
times
what
6.
I was
Yep. I'm gonna put it up here. Yeah, that's perfectly good. Start with 10 times 6 and then break it down into prime numbers. So you have to basically find the prime factorization of 10 and then the prime factorization of 6.
Can we do 5 times 5 times?
What are you getting?
Or since we're factorizing, can we do 10 times,
10 times what?
like 10 times 5?
Well, 10 times 5 gives you 50, so that's not very helpful.
5 times 12.
You could do 5. You can start with 5 times 12 and go that way. It's going to give you the same answer. Let me show you the 2 different ways you can do it. So you can say the factors of 10 are 2 and 5. These are both prime numbers. You can say the factors of 6 are 2 and 3. Both prime numbers. Let's do it a different way. Let's do 60 equals 5 times 12. What are the factors of 5? 5 and 1. And the 1 doesn't really matter. Like you don't have to show 1 when you're doing something like that because anything times 1 is the same number. Factors of 12, 4, and 3. What are the factors of 2? 2 and 2. 2 and 2. So you see our prime factorization is these numbers and these numbers. We've got 2's, we've got 2 2's, we've got a 3, we've got a 5. We've got the same thing on both of them, no matter how we went at it. It's the same prime numbers we end up with. does that feel, Ruth?
I'm still confused.
No problem. Tell me, what do you think? Tell me,
It's like when the number gets bigger, it gets harder for me to factor them.
yeah, you got to this point though, right? 10 and 6.
Mhm.
Can you factor each of these individual numbers? So when you factor 10, what are the factors of 10?
2 and 5.
2 and 5, yeah. And the factors of 6,
2 and 3.
2 and 3. You just keep them all together, that's it.
So I can do them separate.
Yeah, you can do each of the factors separately, yeah. And then here, this one was harder because we had to do a third step. 5 times 12 is 60. At least I think I trusted you on that. That's true, isn't it? Yeah, that's true. What are the factors of 5?
1 and 5.
1 and 5. And the factors of 12, 3 and 4. And then we gotta do 4 again, it's 2 and 2. And you're only looking for the prime numbers. And
So you have to do 4 again because 4 is not a prime number, it's a
Correct.
net number.
Yeah, correct. That's exactly right. Let's do it one more way. 60. 60 is fun because everything wants to divide into 60. Let's do 60, and then why don't you start it this way this time? 30 times 2, and then try to factor. This one's going to take a lot of branches. When you're running the other thing, block one mouse drawing out and talking too much. Did we get a first factorization from here?
For 30?
Oh, that color is not good. I hope you can see it. Yeah, from 30. Did we get a factorization for this one?
5 and 6.
Is that what you got
For which one?
for 30 here?
Oh, I was like 1, 2, 3.
Oh, looking for factors of 30?
Yeah.
Yeah, well, what? Give me some, because you can actually go different ways. So, well, I'm gonna do the other. Let's follow Chantel's, and then we'll do another way. So, what do you get here now, Chantel?
So I went to 6 and I did 3 and 2.
3 and 2. Good. And so, if we look at the prime numbers, we get 5, 3, 2, and 2. And again, that's the same thing we got earlier for 60. Let's do it this other way. Let's look at what goes into 30. Times 2, 2 is prime, don't do it. Now, you said like 3, so what if we had 3 times 10? Seem reasonable? We could even do 2 times 15. I will do that next. Then we get 2 and 5. So once again, we have 3, 2 2s, and a 5. Same prime factorization. See, this is like many ways to get to the prime factorization. It's like, I don't know, there's nowhere, it's like actually New Haven. If you drive on the highway in Connecticut, you probably go through New Haven. No matter if you're coming from Stamford or Hartford or, not Danbury, Danbury's crazy. Or like New London, you're gonna go through New Haven, go to any of those places. Let's do one. We could even do 2 times 15. 3 times 5 is 15. So once again, we have 2 2s, we have 3 and a 5. So it's a prime factorization of 60 another way. Let's try. This. Let's try. Here's a good number. 48. And I'm gonna come look and see how each of you are doing it and guide you. And it's fine if you do it different ways. You just need to see how you each do it. I gotta think about it real quick.
Can you do 24 times 2?
Yep. Yep, so do 24 times 2 and then carry on from there. Let me see which numbers you picked, Chantel.
I didn't pick any number,
Yes,
just trying to figure it out.
Try for some that's not 24 and 2. There are several more that are smaller. 48 is fun. It has a lot of ways that it can become a bigger number. Not bigger number, a smaller number. Oh, I'm sorry, you got an annoying desk. It's like rocking.
Is it 6? I don't know.
Yep, it's 6. 40, 8 times 6 is 48.
Yeah, because I put 24 times 20 and I put 6 and 12.
Good. Now,
Factors is 24.
that's great. That's the correct step. Now, are both either of these prime numbers? No. What goes into 6?
3.
3 and
1 and 3. Well, 2.
2 and 3. Yeah. So you can do a little tree with those two numbers.
So 3 and 2.
Now, what about 12?
3 and 6.
No, that's 18.
I mean-
3 and 4. Yeah, 3 and 4. Now, one of those is not prime.
One of them is not prime 4.
Yeah, so what is that? If you do the prime numbers of 4, prime factorization of 4,
2.
2 and
2
Two.
and 1.
just 2 and 2.
2 and 2.
Yeah, so you've got to do both 2's there. So what are we doing there? So now your prime factorization is 3, 2, 3, 2, 2. So,
2, 2, 2.
yeah, so 2 3's and 3 2's.
So you got 3 2s.
Or 2 3's. That's, let me see. It has to come out the same, so I'm looking to see what is different.
Probably right.
Oh, I see what happened. So 2 times 12 is 24. So this should just be a 2.
Not a 6.
Yeah, I didn't notice that. I'm sorry. Yeah, 2 times 12 is 24. And so these just go away. These
These?
2 below, yeah. So now you get 2, 3, 2, 2, and you have 2, 3, 2, 2. 2,
2, 3.
2, 3, 2, 2. How many 2's do you have? 4 2's. Sorry, I gotta turn this around. There's a third. How many 3 do you have? 2 3's? 1 3. Okay, yeah, so you have 4 3's. So there's also this 2. I forgot about this one on top. So you got 1 2 3 4, 4 2's, and 1 3. So you got 1 2 3 4, and then a 3. So that's the prime factorization of that one. I'm gonna put some practice problems on Canvas for prime factorization, just so you can keep getting comfortable with it. And I'll put the answers up too. The last topic with factors is let's talk about the greatest common factor of a number. So let's say we have 6 and I should title this greatest common actually don't want to do 6. I'm gonna do 12. And I want to do 8. So when we're looking for the greatest common factor, we're looking for the number of these factors, the biggest one that goes into both of them. So I'm going to give you 2 steps. List all the factors. Second step, choose the biggest in common. I don't know why I started writing in all caps. Biggest in common. So now we're not doing prime factorization, we're just doing regular factorization. So for 12, we have 1 and 12, we have 2 and 6, we have 3 and 4. The factors of 8 are 1 and 8 and 2 and 4. That's the hard part.
4, 8. Okay, so the 8 I got right, but 12 I put 8, I put 10. 1, 2, 3, 4.
Yeah, because we had to just pick all the numbers that add together in 12, and then you put them in a line in the smallest to biggest. Because for 12, it's 1 times 12 equals 12, 2 times 6 equals 12, 3 times 4 equals 12. For 8, it's 1 times 8 equals 8, 2 times 4 equals 8.
So the greatest common factor is 4?
It's 4, yeah, it's 4. Good. I just want to cover that, so in case you see that question, they say find the greatest common factor, you're not like accuse me of never telling you what that was. So you just gotta find those. I think that's fine. If I asked you what's the greatest prime factor of 12, what would you say?
The greatest prime factor?
Yeah.
2.
3 is prime.
Oh,
Three
shoot,
is
yeah,
fine.
3.
Oh, I thought you meant like.
But I thought it-
number.
yeah.
That's not, sorry, not in common, just the
12,
greatest.
then yeah.
The greatest prime factor. There's a question on the homework that asks that. Some of the questions might also ask what are common factors.
Okay, so that would be the greatest prime factor.
Greatest prime factor. And in that case, I'm just asking about 12. I'm not
12,
asking about
okay.
8. Yeah. So let's get into orders of operations. Do you all need like a 5-minute brain break, or you want me to keep going?
You can keep going. What do you think?
I'm not gonna get all the material, well, I'll push part of it to next week, because I wanna make sure you're actually understanding. Order, I'm not gonna rush through anything. Order of operations. So when you do math, if you're a good law-abiding math citizen, you've gotta follow rules on what steps to do your math problem in. Because sometimes you can get really long math problems and you don't know which ones to do first. It's not like reading, you can't always go left to right. Left to right is your default, but you can't always just do that. So the way we remember what order to go in is this. Yeah, please just,
They
please-
changed it.
please excuse my dear
Right,
honest.
I'm sorry.
Yeah.
I just learned that on March the
But I thought we
6th.
changed that though. That's what they taught you in high school, but when you went to college, they changed it to something else.
Is it like my dear aunt Sophia or something, or not?
I don't
No,
know.
I mean,
I'm
they-
asking for some reason.
This should hold you. There might be something weird with like prime roots or square roots or something, not prime roots.
But that's kind of funny. Please excuse my dear
Yeah,
aunt.
I know,
Sally.
like,
What does
high
Sally
school.
do?
And then they're like,
So this is how you can remember, and it's telling you what order we're doing operations in. And here are the operations. Parentheses, And we're supposed to talk about exponents in this very class, so, we might not get to it, but, division, addition, my hand's about to fall off, subtraction. So please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. So for this week, this tells what order we're gonna do problems in. So I'm gonna do 2 example ones. I think I've got room here. 9 times 12 minus 8 plus 28 divided by 7. So we've got to figure out the answer to this knucklehead. Now, when we look at these, do we see parentheses? So that means whatever's inside parentheses we have to do first. So what does that mean we're going to do first here?
Subtract 12 from 8.
Subtract 8 from 12, yeah. We're going to say 9 times, what's 12 minus 8? 4 plus 28 divided by 7. Oh, divided by 7. Now let's look.
Exponents.
Multiplication, division are funny. Exponents, there's no exponents here, so we can forget that. These, you actually go left to right doing these, but if it was only multiplication, division, we go left to right. Here we're gonna go 9 times 4 because it's multiplication that's separate by addition. So what's 9 times 4? 36 plus 28 divided by 7. Next step is division. So what can we divide here? 28 and 7 is 4. 36 plus 40. Plus 4. No, not 40. 40 is the answer. And now all we have left is addition, so the answer is 40. Easy enough, right?
So you take the test.
Yeah, go take the test tomorrow. Blindfolded. I'm not going to necessarily work this out on your own, but I'm going to have you tell me what to do. 10 squared minus 3 squared times 6 minus 3 times 2. Alright, so if you are unfamiliar with what exponents do, that's fine, I'll talk about that as we're doing it. But what step would you all like me to do first here?
6 take away 3.
Say again?
6 take away 3.
Yep, we're going to do the subtraction. So 10 squared, parentheses, 3 squared times 3 times 2. What would you like me to do now?
Exponents.
Okay. Which exponents? I can just do both of them, can't I, here?
Yeah.
So do you know what 10 squared is? Are you guys familiar with if I say that?
Is it multiplication?
That would be 20.
No, what it
Because it's
means,
10 2 times, isn't it?
it means 10 times 10. And so 3 squared is 3 times 3. So what would 10 squared be? 100. What would 3 squared be? 9.
Oh yeah,
That's 3 times 3.
multiplication, yeah.
Now I'll bring these down. 3 times 2. Now we've got, what's next?
Randall, I'm not getting you wrong. I'm thinking that it's 10 to the second power, then that would make it 20.
Yeah, I haven't even gone through exponents, so it's fine if you're not familiar with that one. That's completely fine. So what's 10, so what do I do, what do you want me to do next on this one?
It's multiplication.
Okay, so which one do you want me to multiply? It doesn't matter, but 9 times 3, yeah. 27 times 2, 100 minus, nah, that's not fun, whatever. What do you want me to do next?
Still multiplication.
Yeah, and it's which ones? 27 and 2? That's 54, just tell you. do 100 minus 54. Can you do that in your head? No. Don't calculate it on the ASVAB.
I hate that.
Yeah. No more water.
45.
56. Wait,
56.
46.
46. Yeah. 46. So that's order of operations.
So that's the answer?
Yeah, the answer is 46. All right. One more topic for today, and then we'll be done. Other than I'll do like a very rough introduction to exponents, but just enough that you can do the practice for this week. Not actually, we won't actually do the exponents quiz. I'll push that back the next week. So solving equations, AKA your favorite topic, probably the word you grew up dreaming about. This beautiful, look how beautiful that word is. Can you read cursive? I just did it to be like fancy, but algebra. This is technically algebra. What?
There's nothing fancy about algebra.
Nothing fancy, but it sure is pretty. Basically, all it is that's like a funny thing to say because it's gonna get very complicated. But we've got three things in a problem. We've got an equal sign in the middle. We've got something called a variable. And this can be any letter. It's usually going to be X. I'm pretty much always going to use X. So they might use Y, they might use Z. Any letter, it just represents a number we don't know. And then there's going to be a number. And our goal, what we want, is we want there to be the variable on the one side, and we want the number to be on the other. It's like fire and gasoline. We would prefer to keep them separate from each other. Although once they get together, you can't really separate them. So we want to get them all separated. So we want it to look like X equals a number. For example, X equals 3, or X equals, here's a fraction, 3/4. So that's how we want it to look. Now we're going to get problems that that don't look like that. They're going to have maybe the letters or variables on both sides, or they're going to have numbers on both sides. What we do is move variables to one side and numbers to the other side. By doing the opposite operation. So that stays in camera, but in the opposite operation. My hand's gonna fall off. So what are the opposites? Subtraction and addition are opposites from each other. Multiplication and division are opposites from each other. So let's show an example of what this looks like. Let's say x plus 8 equals 12. Now we want the x on one side, we want the numbers on the other side. What is this number doing with x here? Being added. So what's the opposite of addition? Subtraction. So we want to subtract from each side. Now, what's 8 minus 8? 0. That's good. But we want to get nothing but the x over here. What's 12 minus 8?
4.
4. There's our answer for that one. Let's try this other one. Another problem. X minus 9 equals 25. All right, so what do we need to do here? What? Yeah, adding is the opposite. What are we going to add?
Plus 9 on both sides.
Plus 9. So this is like adding So remember we talked about the negatives, it's like -9 plus 9 is 0. 25 plus 9 is,
Wait, we're not adding the 9 to the 9?
we are. Yeah, we have -9, this is effectively a -9, we're adding 9 to it.
So it cancels.
It cancels out. It becomes 0. And that's back, go back and look at what we talked about with the negative numbers and everything. 25 and 9, 34, yeah. So we get on the same side again. So why don't you all try this one on your own. 14 equals x plus 3. Why don't you all try that one?
Are we doing -14, -14, or -3, -3?
I'd recommend doing the 3 because you want to get the letter on its own.
So then the 3 and 3 cancels out?
Yeah, because and what are you doing to the 3? You're subtracting. So what do you do to 3 over here? Subtract as well.
So the answer is 11?
Yep, the answer is 11 equals x. And try a not more complicated, a different kind. Now we have 3x equals 9. And what that means is 3 times x when we say 3x. So what's the opposite of multiplication? So instead of doing that kind of sign, I'm going to do the fraction sign. So I'm going to divide each by 3. And so what do we get x equaling? 3. 9 divided by 3 is 3. Now I've got x divided by 5 equals 7. What's the opposite of division?
Multiplication.
So what should I multiply this by?
7.
Not 7 because
1.
no, not 1. It's got to be something that would get rid of the 5.
Oh, so would it be 5 to
It'd
cancel
be
it out?
5. We multiply it by 5. X equals 35. Because when you have a number on the top and bottom, it cancels out. But the easier way to remember is it's divided, the opposite is multiplication, so multiply it by the same thing. Alright, let's try this one. Now we're going to combine them, do some real math magic. 2x plus 4 equals 10. Now I got two things going on. What are you going to suggest we do first here?
Cancel out the x.
The x?
Well, no, so wouldn't it be -2?
Well, this is 2 times x. So the opposite would be division.
Oh, okay.
What about this 4 hanging out? Why don't we
So
get it?
divide the 2 into 2.
Can't do that because we have this 4 hanging out. You got to do it to the entire side when you do it.
4 divided by 10?
But you can't divide 4 into 10.
What if you subtract 4 and get it over on this side?
Subtract
yeah,
4
because
and make it a 6? Oh.
Yeah.
See, I was
This
thinking,
way.
because I was like an X. So
Oh,
I'm
which
like,
one? Which one?
So
did?
I didn't know if that was X and then
This
4
one?
or, yeah.
Oh, sorry. Well, I can't really. I add. So 2x equals 6.
6.
Now what can we do?
Then you put them on both sides, so cancel out that, wait. So it'd be 2 divided by, 6 divided by 2,
Okay, and then what are we doing over here?
and then put division 2.
Yeah, so that cancels
Cancel
that out. X equals 3. So when you've got them like, when you got it like we had here with something X and then a number, the first thing you want to do is get rid of the numbers. That's easier to just get rid of the number and move it to the other side. So here's one, a little more complicated. I see you smiling. And I know we get 3 minutes left to wrap it up. 5x plus 3 equals 2x plus 9. Alright. So here, we need to move our x's over to one side and our numbers over to one side. I'm going to show you how I do this. I'm going to move the numbers first. It doesn't really matter which one you move first. But I'm going to move the numbers first. 9 minus 3 is 6. So now I have 5x equals 2x plus 6. Now what you're going to do is you're going to move the x's over to the other side. This is a new thing. So you can say minus 2x minus 2x. You can say 3x equals 6. So see, you can subtract x's as well. Like that's fine. You can subtract them, divide them, cook them in the stew, whatever you want to do. Now we can do the division.
Wait a minute.
You exit out 2x.
Yep, because I subtracted 2x from both sides. So they've got all my x's on one side. Because we're always trying to give the x's to one side and the numbers to one side.
So why did you, I get it, but I don't get it. So why did you cancel out the 2? Is it because the 2 is the smallest number versus the 5?
Yeah, like so I could have done it this way. 5x plus 3 equals 2x plus 9.
It would still equal the same answer.
Yeah, I could do this. I could do minus 5x. But then I'd need to bring the numbers over here, so I'd have minus 9, minus 9. So what I get when I do it this way is negative 6 equals negative 3x. I'm going to get the same answer. Negative 3 divided by negative 3 and negative 6 divided by negative 3 is 2 equals x. I get the same answer, but when I did it that way, I didn't deal with all these negative numbers.
Okay.
You're gonna know how to do negative numbers, but in math, especially without a calculator, you want to avoid making them when you don't have to, because they're super easy to make mistakes with, because they often go opposite what you think. So if you can help it when you're doing math problems on tests like ASVAB, stay away from the negative numbers. Sometimes you have to, but if you can help it, stay away from them. So do you see why I moved the 2x to this side? Why I moved the 2x over there now?
Yeah.
So last thing is 8:30. If you'll give me like 2 more minutes, I'm gonna have you both work one, and then we'll be done for the day. And while you're doing that, I'm just gonna write an exponent definition. So 29 equals 4x minus 3.
So do I end up with 29 equals 7? If we're doing add 3, because that would be the opposite of negative.
So add 3.
Oh, it's the 29.
You gotta add 3 to both sides, yeah.
No, yeah, but I added to the 4.
Oh yeah, no, you wanna add it to the 3.
The first number.
The 3, you wanna add, you just got it to both sides, so you add it to the 3. These go away. 4x equals 32.
32 equals 4x.
Yeah. Now what's the only thing by itself that, well, you want the x to be by itself.
So
So,
it'll be -4, -4.
no, you're not subtracting, this is a multiplication. This is the same as saying 4 times x. So what's the opposite of multiplication?
Division.
So what can we divide 4x by?
2.
By 4, because 4 by 4 is 1. 32 divided by 4 is 8 equals x. Last thing, we'll actually do exponents next week. When you see the exponents, it'll say like 3 squared means 3 times itself twice, so 3 times 3. 3 to the 3rd power is 3 times 3 times 3. 3 to the 4th power is 3 times 3 times 3 times 3. So 1, 2, 1, 2, 3, 1, 2, 3, 4. Yeah, that's just like a very basic definition of exponent in case it comes up in a question. Gonna stop the video now.